Lunar water linked to solar wind. Latitude and regolith maturity key factors. Study finds lunar water linked to solar wind. Latitude and regolith maturity key factors. Study finds the presence and origin of water on the moon's surface is a topic of growing scientific interest, particularly as it relates to future space exploration and the possibility of utilizing lunar resources. New research suggests that lunar water is largely sourced from the solar wind, a constant stream of charged particles emitted by the sun, and its distribution is heavily influenced by the moon's latitude and the maturity of its soil, regolith. Key findings from the Chang'e 6 mission. A team of researchers from the Institute of Geology and Geophysics of the Chinese Academy of Sciences, IGGCAS, analyzed lunar soil samples returned by China's Chang'e 6 mission, which marked the first time material was collected from the moon's far side. The samples revealed surprisingly high concentrations of hydroxyl, OH, and water, H2O, and exceptionally low deuterium to hydrogen, DH, ratios. These characteristics strongly align with the theory that lunar water originates from the solar wind. Comparing these samples to those from China's Chang'e 5 mission, collected from a similar latitude on the near side, and NASA's Apollo missions from lower latitudes, the research indicates a globally sourced water supply from the solar wind, with its distribution dictated primarily by latitude and regolith maturity, a measure of how weathered and altered the lunar soil has become. The role of latitude and regolith maturity. Latitude, which is closely linked to temperature, appears to be a major factor. Previous observations by India's Chandrayaan-1 mission using the Moon Mineralogy Mapper M3 instrument initially showed hydroxyl concentrated at higher latitudes. While later analyses produced conflicting results, the Chang'e 6 findings reinforce this connection. Samples from higher latitudes tend to hold more water. Regolith maturity also plays a significant role. More mature regolith, which has been exposed to space weathering and solar radiation for longer periods, tends to retain higher concentrations of water. The Chang'e 6 samples showed stronger water absorption signals and higher regolith maturity compared to those from the Chang'e 5 mission, even though they contained similar amounts of water at the grain level. The challenge of measuring lunar water, accurately determining the abundance and distribution of lunar surface water, is a challenging task. Earlier attempts to analyze global data using different thermal correction methods resulted in conflicting conclusions. Researchers emphasized that direct laboratory analysis of returned lunar soil samples provides the most reliable data. Bridging the knowledge gap on the lunar farside prior to China's lunar missions, understanding the composition of the lunar farside was limited to remote sensing data. The Apollo and Luna samples provided valuable information on water content and origin, but were collected from the near side at lower latitudes. China's Chang'e 5 mission, 2020, returned soil from a mid-latitude site on the near side, and the recent Chang'e 6 mission provided samples from a mid-latitude site on the far side. These samples allow for direct comparisons between the two sides of the moon, enhancing our understanding of water distribution. Analytical methods and results. The researchers employed two key analytical methods to study the Chang'e 6 samples. Spectral measurements quantified the overall OH H2O content, revealing a bulk concentration of 183 plus or minus 34 ppm. Nano-SIMS depth profiling measured hydrogen abundances and DH ratios at the microscopic grain scale. This analysis found high hydrogen concentrations, 1,017,500 ppm, and extremely low delta D values, down to minus 983, strong evidence for a solar wind origin. Implications for future lunar exploration. These findings suggest that lunar surface water is likely most abundant in highly mature regolith at higher latitudes. Understanding this relationship is crucial for planning future lunar resource utilization efforts. The research highlights the importance of considering both latitude and regolith maturity when prospecting for water on the moon. The research collaboration involved the CAS Shanghai Institute of Technical Physics, the CAS Institute of Geochemistry, and the China Academy of Aerospace Systems and Innovation. NGT. Ultimately, this study provides a significant step forward in understanding the origin and distribution of lunar water and its potential for supporting future space endeavors.